lunch today is Shilpa Kancharla. I love that I can actually pronounce your name so well. Was that right?
Yeah, you pronounced it.
I love her name, Shilpa Kancharla. I like saying it. She's a former researcher at NASA, and she went to North Carolina State University, which is a super cool place to go. And she worked in the Robot Code Lab. She's talking to us about applied machine learning with KerasCV and KerasNLP, and her term is creativity. So she considers herself a creative data scientist. Thank you.
Yeah, thank you so much. Hi everyone, my name is Shilpa Kancharla, and I'm a machine learning engineer at Google, and I am based out of the San Francisco area, but I flew in today to give this talk. I'm pretty excited to be here, and I guess we can just go ahead and get started. So I'm also pretty new to using this technology as well. It's been recently developed. But these are two new ML frameworks from the Keras team. They are KerasCV and KerasNLP. And there's been a lot of new developments in machine learning and AI, as you all know, in recent years, whether it's new types of models or the recent surge of generative AI and how much it's being used. But I think one challenge through all of that is trying to keep up with training state-of-the-art models. So you can think of models like BERT or ResNet or other types of computer vision and natural language models, which I'll be talking about today. And the main challenge that comes with a lot of these is the training, how computationally expensive it is. So a really great thing about these two frameworks is that it kind of takes away some of that complexity and some of that burden on the user themselves. So they basically allow you to perform computer vision and natural language tasks a lot faster than you might have before. And I have two examples shown right here. So one is text classification, and what you can see is basically in a few lines of code, you can use the BERT classifier to fit onto a data set and also perform your own predictions. And this is done maybe with, I think, about 4 lines of code. And then right next to it, you have generative AI, which we also offer, and that's text to image. So within maybe 2 lines, calling 2 commands, you can pass in a prompt and you can get an image from that. So I'll begin my talk today kind of talking about KerasCV and introducing it first. So right now, let's start off with the most simplest, kind of the more simpler task of image classification. So right now, the task that I have here is I'm doing a basic identifying dogs and cats, right? I'm giving dogs a 1 or positive, and then cats -0. And what I have here is the code to do this with. So again, there's about five function calls here, and the highest level that you can see here is called a task. And the task here is called image classifier, as I've imported. And then there's also a pre-trained backbone called the ResNet backbone, which I load in with a particular preset using the from preset constructor. So the one that I've chosen in this example is called ResNet50_ImageNet, and this is the ResNet that's been used in ImageNet classification. And here's where the part that I was kind of mentioning about saving time on training and kind of that reducing that computational cost comes in. Because you're using a pre-trained backbone, you're essentially cutting down on the amount of training time that you would normally have to spend if you're training this from scratch. So ImageNet, it comes with, this backbone in particular comes with a lot of training parameters that were used to grab, say, the most important features off of a very large data set. So that's the backbone that you're including. And then I think from there, it's the pretty standard TensorFlow Keras workflow that you might be familiar with if you've used these two libraries before. So you have your model instantiation in that third block right there, and you can pass in the backbone, and you can also pass in the number of classes that you're interested in. And then from there, you can call model.compile and then model.fit to pass in your particular data set. And I think that's it for this slide, all I wanted to mention. So I'll go ahead and move on to the next one. Okay, so object detection, also a computer vision task, a little bit more complicated than just simple binary image classification. But it kind of follows the same workflow, so I've imported in the backbone and the task. In this case, it's RetinaNet, as opposed to how it was image classifier before. And I've also loaded in that preset as well. And from there, I've specified the backbone, the number of classes I want to include. And this time, because I'm using an object detection model, RetinaNet, I also have to include the bounding box coordinates. But the documentation that we provide on keras.io kind of goes along with maybe how you would format those bounding box coordinates. So I'd strongly recommend you to look there if you're interested in maybe adapting it and creating your own object detection model. And then from there, the other two commands, if you've used the TensorFlow Keras kind of setup you're familiar with, model.compile and model.fit. Okay, and then, let's see. Backwards. Okay, and another really important part of computer vision, I think machine learning in general, is data augmentation. So data augmentation is super important because you want to prevent overfitting, and you also want to introduce some kind of variety into your data. Maybe you do this to cover edge cases, whatever it might be, but it's a very important step. So within the KerasCV framework, there's also ways to do data augmentation as well. So you would have, basically you would create a sequential model typically that you do from Keras, and then you can pass in these different augmentation layers. So I'll introduce a couple of them here. Random flip is for rotation, so if you want to rotate your data to be a different orientation. Random augment is for intensity perturbations, and cut mix and mix up are for creating composite images. So you can see the original collection of images of flowers, and after I apply the augmentation, what they kind of look like. Like you can still see that they're flowers, but they are very different from your original data. So we just offer a way for you to perform this in a few simple calls as well. And then next, I think this is a very hot topic within machine learning today, and that's image generation or using generative AI capabilities. So we have the stable diffusion model, and from here you can see that just basically 3 lines: import statement, model instantiation, and then actually creating the images, right? So you can specify the image parameters, the width and the height. I think the default is 512. I think you can go in there and change it. And then from there, that function where it says model.text to image, so that's what's kind of the main workhorse here, and you just pass in the parameter there. And then batch size of 3, you get 3 images. So right now, I think our pretty standard example is a photograph of an astronaut riding a horse. And I think from there you get 3 novel images like this, and it's pretty close to what you prompted the model to produce. And then you can also do a bit more with stable diffusion as well. You can do textual inversion, in which you keep modifying some input to the image. So in this example here, we took one of our teammates' cats, and then we said, okay, we want to take this input and turn it into a fantasy character. So that's kind of what we have there on the bottom. And then there's also prompt to prompt, where you modify just part of the prompt. So instead of a photo of a dog with sunglasses, you have a photo of a cat with sunglasses. But you can see between the original and the newly produced image, the concept is pretty much the same, the same background, same pose, same position of the ears, and same kind of like how they're facing up. So there's a lot of similarities between your original image and the image following it. So just, textual inversion and prompt to prompt are two ways that you can kind of play around with generating images. Okay, so that's kind of a brief introduction to KerasCV, and I'll go on to talking about KerasNLP now. So let's start with text classification. You want to, here you're trying to just, I think, take the IMDb movie review data set, and then we're going to perform some classifications on strings later on. But to start this, you want to instantiate the BERT classifier, which is a pre-trained model available in this framework. So you instantiate that, you call from preset like we did before, and then you, in this case, we're using the BERT _base _English uncased backbone here. And we're setting the number of classes, and you can also set an activation function. So from preset actually contains a lot of different potential parameters you can pass in. So you can kind of look through the documentation and see maybe where you would like to customize that initial model further. So then from there, it's model.compile and model.fit onto your dataset. And then you can do .predict, and you can see like, okay, is the review negative or positive in this instance? And what you get in return is this probability array. And with about, I think, 99% confidence for each of these different pieces of text, you get a score. So it's saying the first one is positive, second one is negative. And then another generative AI task that we can do is text generation. So just pass a data set of text into the causal LM model here. And in this case, I think we chose CNN Daily Mail dataset. And then, before I go on, also talk a little bit about causal LM. So causal LM is a task that predicts each token in an input sequence given all the preceding tokens. So kind of think about autocomplete, it's predicting the next word. So that's what causal LM is doing. And yeah, so similarly like before, we've called the task GPT-2 causal LM from preset to specify the backbone, and then compile.fit. And then from there on, you have a pretty much autocomplete task at your hands. So for example, model.generate, I'm gonna pass in snowfall in Buffalo. The maximum length I want this response to be is 40, means 40 words. So I get back, snowfall in Buffalo, New York was expected to reach 2 feet by the end of the day, according to the National Weather Service. So it was trained on a set of documents from the CNN Daily news set, so that's why it kind of has that news format. But I think if you could train it on any kind of data set you have, it just kind of depends on what task you're going for. Okay, and then the Keras API philosophy. Okay, so there's this concept that we use called the progressive disclosure of complexity. So depending on how customized your particular task is, you can take different components of the API off the shelf for yourself to use, and you can kind of build that complexity. But the point is, you don't have to start with something very complex. You can start simple and then build up. So what I mean by this is, say, for instance, you want to do something like custom pre-processing. Okay, so this is like the breakdown of the different modules within the Keras API. And in this context, I will talk about KerasNLP specifically. So you start with a task, which is the BERT classifier, and from then it's broken down into the preprocessor for your strings, and also the backbone or the pre-trained weights. And then the preprocessor also has a tokenizer, so how it basically tokenizes each of the strings. And you can see in each of these different components, there's a from preset constructor, meaning that you can customize every single model component in a sense. And then in this example I have right here, again, I'm talking about custom pre-processing. So say you don't want to use the default pre-processing that a task already comes with. That's fine, you can change it. And how you do that is that each of these different models contains a preprocessor component themselves. So BERT classifier also links to a BERT preprocessor. So you can go in there and you can kind of customize what you want to do from there. So in this case, I've called that preprocessor module and I'm setting some parameters that are more explained in the documentation. And I'm saying, okay, I want to use that specific backbone for the preprocessor with that sequence length. And then I'm going to take that preprocessing function, I'm going to map it to my training data set, and then I'm going to save it using .cache. So going from there, I don't know if you can see that up there, but it says model equals BERT classifier from preset. So again, I'm trying to instantiate the model here, right? But I've already created that preprocessor function before, so if I don't want to duplicate that effort, I pass in here specifically preprocessor equals none, so you're not kind of stepping on the preprocessor that you've already created. And then I've set the number of classes, activation, model.compile, and then I'm fitting it onto the train data set that the preprocessor function was applied to. And then I'm going to go ahead and train it. And then what's really great too is, I think one really hot topic within machine learning is also transformers. And I think there's been a lot of, in a way, I think if you're new to machine learning, I know when I was first learning about transformers, I had a very difficult time even understanding what they were. But what's really cool is that concepts aside, I'm able to kind of build one using KerasNLP. So I can teach myself, as I'm setting up each of these modular components, maybe what that maps to in an actual transformer. So I'm going to kind of show maybe one way you can build that transformer here. So you can even go down as far into token and positioning embeddings. So when you embed a string to be passed into a model, and then the encoder layers. So these are also, there's a lot of different layers within KerasNLP. So you can take like each of these things and build something more complex. So if you want to do this, you have to use the Keras functional API. And how that basically starts off is setting up an input tensor. So that's what that first thing is here. Token ID input is a Keras input. I've kind of specified the shape of that tensor. And then the output from that is the embedding. So you get the token which is the tokenized string. I pass it in, and I'm specifying what I want the dimension of my embedding to be. And so in Keras functional API, what you would do to do that is you would basically, like I have here, set the token and position embedding call, and then in parentheses next to it, set your previous thing that you've defined. So in this case, token ID input. So that's how you would get the output. Okay, and then, yeah, from here, I'm just building up the neural network, or the transformer. And in that for loop, for whatever number of layers I want, I have a bunch of encoders that I'm adding in with that specified dimensions there. And then the outputs will follow after. So that's, again, the Keras functional API syntax. And from there, I can finally output it to 2 dense layers, and then that's what will produce my output. And then, yeah, I go ahead and instantiate that model after I've kind of written it all out. And there's a lot of different moving parts in the TensorFlow ecosystem. What you might use depends on you. So for example, there's TF-Lite or TF.js. These are kind of on-device machine learning platforms. So like say if you want to run an ML program within an app, right, on your mobile phone, you might consider using TF Lite in this instance. There's actually a workshop that was put out at Google I/O about running ChatGPT on a simple app. And that, I would suggest you guys take a look into that. I think it might be provided in the resources slide. And then we also have XLA and TPU. So that's just-in-time compilation for faster inference. And then dtensor is a multi-accelerator inference. So depending on what you want to use, there's a lot of different backends that are compatible for this. So it really depends on your use case. And then finally, before I wrap up, I'll just leave you with some resources. So I've mentioned it a couple times, but the documentation is a really great way to learn about all of these. That's kind of how I've been picking up on it. And there's a lot of community examples other people produce and put up there. People take the Keras stuff and then they make it into more complex projects, which is always really great to look at. And then you can also take a look at the GitHub for each of these if you want to know more about the inner backend, what you can update and modify. But I think that's all for me today, so thank you so much.
Thank you, Shilpa. We can take 5 minutes for questions if that's okay with you.
Yeah, sure, we can do questions.
Okay. What do we got? Anybody? Okay, we got one right here.
Just a quick question. I mentioned it's probably one of the sort of keywords in there, but if you're monitoring, through each epoch, various logging, what does that sort of look like? You keep various metrics, and I want to put it into a logger. Just what does it look like?
Okay, so typically, when it comes to metrics for the TensorFlow Keras ecosystem, I know one, besides it printing the output inside the console, I think a better way to monitor that is to actually use a tool called TensorBoard, so you can keep track of different, maybe different runs you make, what tweaks you make to your model along the way, and that's how you can keep a log of whatever metrics you're trying to track.
Great. Any others? Got one up there? All right.
Hi, thank you. I have a couple of questions. One is, recently we got surprised by Keras supporting PyTorch as backend. How do you see this going to evolve as a product? That's one of my questions. Second question is that when do you recommend people using Keras as well as going back to the TensorFlow as native? Because there seems to be a lot more overlap. I can directly sometimes do in TensorFlow, or I can stick to Keras. When do you think the granularity matters? How do you think, as a developer, hey, you start with Keras, but if you can't do certain things, switch back to TensorFlow? Can you comment on those two questions, please?
Yeah, sure. I'll start with your second question because I think that's a longer response. So basically, yeah, you're right. There's a lot of different tools and frameworks out there. When do you use each one? I would say the question between TensorFlow and Keras, you use them hand in hand. TensorFlow is kind of that back-end ecosystem that provides all the computational engine, and Keras is the framework that sits on top of it. So that's general Keras, right? And you also use TensorFlow as kind of your computational engine for KerasNLP and KerasCV. But I think besides what is normal Keras, when would you use the CV and NLP ones? I think if you are, in particular, if you're interested in a pre-trained state-of-the-art model, but you don't want to spend all your time training something from scratch, if you know it's going to be computationally expensive, then that's when you can look in to KerasCV and KerasNLP to get those state-of-the-art models to implement and customize them on your own. And then, could you repeat your first question again? Sorry.
The support PyTorch.
Okay. Okay, I actually don't know anything about the support in PyTorch. but maybe we could chat about that offline. Yeah,
Excellent. Thank you, Shilpa.
thank you.